Example number 4, we're going to write each expression as a single logarithm in simplest form. Then we're going to state the restrictions on the variables. So what we're going to do is we're going to bring those numbers in front up first for a. So it's going to be log base 3 of x to the power 4. We're going to have to distribute this negative into the bracket, the negative 1/2, giving us negative 1/2 log base 3 of x, and then negative 1/2 times 5 gives me negative 5/2 log base 3 of x. So we need to distribute that properly first. And then what we're doing is we're bringing these, the 1/2 and the 5/2 into the power. Don't take the sign with it. The sign just tells us where the number is going to go, so don't take that with it. Leave the negative log base 3 of x, and then we're going to write 1/2 as a power. Minus log base 3 of x, and 5/2 is the power. Now, whenever we have subtractions, those go to the bottom. This addition of log goes to the top. So all of these become one single logarithm when we do these quotient and product laws. So we're going to have x to the power 4 at the top, and we're going to have both x to the 1/2 and x to the 5/2 at the bottom of the fraction. Now we're going to be able to simplify this because the bottoms, whenever we're multiplying, we actually have to add the powers together. So it's going to be 1/2 plus 5/2. And so 1/2 plus 5/2 is 6/2, so that's going to be x to the power of 3. And that will simplify to log base 3 of x4 over x3 is just x by itself. So if you were to graph this, you would actually find, since there's no horizontal translation, we know that there's going to be that vertical asymptote at x equals 0. So that means the graph has to be greater than 0. So our domain, or our restriction in this case, that's what they're calling it, is the graph is going to exist where x is greater than 0. For B, it says that we're going to have to divide the x squared minus 9 and the x squared minus x minus 6. We're going to divide them. So what you'll notice is that the x squared minus 9 goes at the top, and then the bottom, because it's following a subtraction, goes to the bottom, the x squared minus x minus 6. This is a rational expression that we're going to have to simplify. So we're going to write difference of squares at the top, and at the bottom we can factor it fully. Two numbers that multiply to -6 and add up to -1 would be x minus 3 and x plus 2. So the x minus 3's cross each other off, leaving us with log base 2 of x plus 3 over x plus 2. Now we're going to have restrictions here because we're not allowed to have 0 in our denominator, so we know that that value of -2 is not going to be allowed. But what we want to do is we want to figure out what the restrictions are, what's the most restricted area from the top and the bottom, and kind of use that. So if you graph this, this will kind of give you a better idea of this. So I'm actually going to graph this function to look at the restrictions. It makes it way easier to see it. So for the newer version calculators, you're going to have to do alpha window number 5, and you're going to have to put that base of 2 in. And then at the top, you're going to write x plus 3 divided by, in brackets, x plus 2. Close your brackets. Now we're going to use the standard window. So -10, +10, -10, +10, and then what we'll do is we'll graph it. Okay, so what you'll notice is that there's kind of like two areas. There's a graph where if you look at the graph, we're not allowed, it seems like there is at x equals -2, there's a value that we can't have. And we also want to look at where x is less than -3. So it's kind of in between those areas. So our domain, let's write that out. We're going to say that our graph is going to exist, our restriction is going to be where x is greater than -2 and where x is less than -3. So if we look at the picture, that gives us a better estimation of it instead of just guessing. So I'm using the domain where it's less than and greater than. Okay, so that graphing it helped me figure out the restriction. So that's what I did. I looked at the asymptotes, and there was like two things I had to look at where the graph was greater than and less than a certain value. So use that as a good kind of note for yourself. Okay. Example number 5. It says if log 3 equals p and log 5 equals q, we want to write an algebraic expression in terms of p and q for the following. So we need to figure out a way to make sure that we see log 3 and log 5, and then once we do, we'll replace it with p and q. So, so far we have log 3 multiplied by the square root of 5. So these are our values. Anytime we have multiplication, we can write it as addition between two logarithms. So I'm splitting them up using the product law. And then I already have that log 3, which is good, but I still want to get log 5 by itself. So what I'll do is I'll write 5 to the power of 1/2 instead of that square root. And then using the power law, I'm going to bring that 1/2 in front of log 5. And lastly, I'm going to replace log 3 and log 5 with my p and q. So p is going to replace log 3, and I have 1/2 q. And that's it. So that's how I've replaced those two values into there, so I don't have anything else other than numbers and p and q. Example number 6, we have the pH scale is used to measure the acidity of alkalinity of a solution. So we have the pH of a solution is defined by this equation. pH is equal to negative log H plus. H plus, so hydrogen plus, is your hydrogen ion concentration in moles per liter. So a neutral solution is going to have a pH of 7. Anything less than 7 is acidic, anything more than 7 is basic or alkaline. And the closer a pH is to 0, the more acidic the solution is. So the lower the number is, the more acidic it is. So a common ingredient in cola drinks is phosphoric acid, the same ingredient found in many rust removers. A cola drink has a pH of 2.5. Milk has a pH of 6.6. How many times as acidic as milk is a cola drink? So a little hint to you guys is whenever we're going to try to change or compare something, we actually need the concentration, the hydrogen ion concentration. So we're going to use the equation pH is equal to negative log of H plus. We're going to fill in the 2.5 into negative log of H plus, and we're going to solve for the H plus. So we're going to move the negative to the other side first of all. So that gives us log of H plus. And then we're going to change it to exponential form. So the base, if you don't see it, is a 10. So it's going to be 10 to the power of negative 2.5, and that's equal to your H plus. Now the same is going to happen here. I can do all the work, but you're going to find that the concentration is going to be 10 to the power of negative 6.6. Now when we compare numbers to figure out if something's more acidic, we always have to put the bigger number over the smaller number. Now the bigger number is 10 to the negative 2.5 because negative 2.5 is larger than negative 6.6. So when we divide them, make sure you put the larger exponent at the top. And then what we can do is we can go 10 to the power of negative 2.5, subtract negative 6.6, because anytime you have division, you can subtract the powers. So that becomes 10 to the power of negative 2.5 plus 6.6. So then we can simplify those numbers. Negative 2.5 plus 6.6 equals 4.1. So we're calculating 10 to the power of 4.1 in our calculator. And we get that the cola drink is 12,589 times more acidic than the milk. Now an apple is 5 times as acidic as a pear. If a pear has a pH of 3.8, then what is the pH of the apple? So what we're doing is we know that the apple is 5 times. We know the answer is 5. And whenever we're comparing, we always put the higher pH at the top. So it's going to be the, let's see, it says the apple is going to be more acidic, so that's going to be your top number. So some negative x value over 10 to the power of negative 3.8. Okay, so what you'll notice is that you're going to have the apple being your x, the pH, so that represents your apple pH, and that's more acidic than a pear, so that's why the more acidic item is going to the top of the fraction. So it's going to be 5 equals 10 to the power of negative x, and we're going to have to subtract negative 3.8, which makes it positive. So we're going to have 2 negatives becomes positive 3.8. And so this is what we have to solve for. So we're going to actually convert it into log form. So in order to convert it to log form, it's always log of your base, which is 10, of your answer, which is 5, equals your power, negative x plus 3.8. So all I have to do is isolate for x. So I'm going to put log of 5 in my calculator because you don't have to write the 10 when the base is 10. And you get 0.69897, which is equal to negative x plus 3.8. And then what I'm going to do is I'm going to swap these spots because I want the x being positive. And then I'm going to put that in my calculator. And you should find that the x value is 3.1. So it should make sense. Your number should always be between 0 and 14 if you're doing this properly. So in my case, the apple acidity, the pH would be 3.1. Okay, so that makes sense to me. So what I had to do is just make sure that I figured out which one was more acidic, and I just put that one at the top with the negative. So whenever you're working with pHs, make sure you use negative pH for your powers. That's a little trick that I do. And then what I want you guys to do is practice a little bit with the next kind of examples. And then if you're curious on the answers and want to check with me, just pop me a message and I'll send you the snapshot of the answer key for the examples below if you're wanting to try extra examples and practice. Otherwise, try the ones in your homework. I hope that helped for your lesson of your log laws. This is a really important concept that comes back a lot, I found. So make